So let us continue with what we discussed in the last video. Last video we had started with defluoridation of drinking water. We saw what is the definition, then how is fluorosis distributed in the world, distribution in India, and how it is distributed in Kerala, and what are the optimum levels of fluoride recommended by the various agencies, what are the ideal requisites of ideal defluoridation technique, how are the defluoridation techniques classified, that is based on adsorption, based on ion exchange, and based on precipitation and other newer techniques. And where was the first defluoridation conducted in India, and a few substances that can be used based on adsorption process, including activated alumina, activated carbon, and process bone and bore jar a bit in detail. Then based on ion exchange, we have the cation exchange resin and anion exchange resin. So what are the cation exchange resins and what are the anion exchange resins? This is where we stopped in the last class. Next we move on to the third mechanism, and another important mechanism is based on precipitation. So while in the adsorption technique, as I told you, the fluoride gets adsorbed onto the surfaces and substances you add. In ion exchange, it is basically an exchange with the fluoride ion. And the third mechanism is based on precipitation. Here when you add the ingredients, they combine with fluoride and form precipitates. So this is the basic difference in the mechanism of action of each type of defluoridation technique. So the third type of defluoridation is based on precipitation. The examples of substances that work on this mechanism are lime, alum, the combination of alum and lime, and magnesium salts. First, let us talk about the Indian Institute of Science method. Indian Institute of Science method was developed by the Indian Institute of Science, Bangalore. The reagent that is used here is a combination of magnesium oxide, lime, and sodium bisulfate. Together, they act and result in precipitation of fluoride products. The next is polyaluminium chloride. And the third and one of the most important from your exam point of view is your lime plus aluminium sulfate. And this technique is popularly known as the Nalgonda technique. If you go through the question papers that have been asked so far, one of the very frequently asked short note or short essay question is on Nalgonda technique. Or you can be asked to define defluoridation technique, classify the defluoridation techniques, and write in detail about Nalgonda technique. So this is one of the most commonly asked questions from this chapter. So we'll have to discuss this topic a bit in detail. So coming to Nalgonda technique as such, it was developed by Navlaki et al. Actually, NEERI, I already told you, is the National Environmental Engineering Research Institute at Nagpur. It was used for the first time in Nalgonda in Andhra Pradesh, which is presently at Telangana. So the name is not from where it was developed, because it was developed in Maharashtra, Nagpur at NEERI. But it was used for the first time in a place called Nalgonda, which is an endemic place for fluorosis, and hence the name is Nalgonda technique. So the reagents used in this technique are three reagents. One is potassium aluminium sulfate. You have heard of potash alum. So that is the first ingredient. The second ingredient is a calcium oxide, that is lime. And the lime is added at 1/20th the concentration of alum. How much of alum has been added? 1/20th the concentration of alum is your lime. And the third is bleaching powder, calcium oxychloride. Now the technique involves 5 steps. So it is like you are adding alum and the lime with water. You are mixing it rapidly, that is called as rapid mixing. Once rapid mixing takes place, the impurities form floccules and float on top. This is a process called flocculation. Those which are heavier than water, they form precipitates and sediment below. It's called as sedimentation. And this water is filtered to clear up all the floccules and sediments. And finally, the water you obtain is disinfected using bleaching powder. So the technique of Nalgonda technique of defluoridation, the steps are 5 in number. It starts with rapid mixing of alum, lime, and water. It results in formation of floccules by a process called flocculation. Those heavier form precipitates and sediment below, which is called sedimentation. And this water is passed on through a filtering media, and that is filtration. And finally, it is disinfected by adding of bleaching powder. So for Nalagonda technique to be maximally useful, or for Nalagonda technique to be efficient, it has to satisfy three criteria. The first criteria is there is no other low fluoride source available. That is when you can indicate the use of Nalagonda technique. Second is the total dissolved solids in water should be less than 1500 ppm. If the total dissolved solids are more, it results in the efficiency, it can interfere with the efficiency of the Nalagonda technique. And the third is it should have a total hardness of less than 600 ppm. So only when these criteria are satisfied, the Nalagonda technique that can be used will be most efficient. So the types of Nalagonda technique, you have the first type is called the domestic defluoridation. It is a modified 60-liter bucket, the usual bucket you have. It is modified with a tap 5 centimeters above the base. You add the reagents lime and alum. You give it a manual mixing. Then you use a cloth for filtration, and this defluoridated water is used. So this can be done at every home. It is called domestic defluoridation technique, which is a modified, usually available bucket to fix it with a tap and a filter that is added, and all this procedure are done manually in a bucket at home. The second type is called, for a larger population, it is called fill and draw type. For a small community, when you have a population of a village of around 200 population, you can make a device like this, which is called as a hooper bottom cylindrical tank. So this is a larger tank where the reagents are added and they are manually mixed together, and then the water is drawn from this. So this is for a larger community compared to the other one which we discussed was for specific homes. This is for a small community, maybe around 200 population. You can go for a manual mode of this tank, wherein this is known as the hooper bottom cylindrical tank. The reagents are added and manual stirring is done. Now for a larger community, probably when you talk about a village, you cannot go for this manual mixing. You have a fully automated system wherein lime and alum are mixed with water directly. It goes to a tank where flocculation and sedimentation takes place. The sediments are separated. Then it goes to a tank where there is filtration. Once the filtered water is there, it is disinfected, and then the clean water is drawn. So this is a completely mechanized plant where you don't require a manual stirring. Everything is done automatically. So this is the large plant that is required for a larger population. These are the three ways by which Nalagonda technique can be used, either at every home or for a small community or for a larger population. Now, what are the advantages of Nalagonda technique? This is in comparison to what we discussed as ideal requisites. They employ the use of readily available chemicals, alum, lime, bleaching powder, and all very readily available. They are not very harmful. They are adaptable to domestic use because this can be done even if you have a bucket. It is very efficient. The operation is flexible, acceptable, and all these reagents are relatively cheap or inexpensive, and you require a minimal mechanical equipment unless you go for a large mechanized plant. So it has a disposal. It has a disadvantage. The first disadvantage is the sludge disposal. So this precipitate which is formed is called as sludge. That waste has to be disposed properly. So there is a problem that can arise because of the sludge that is generated. Second is, if you have an excess of alum, as aluminum taste can come in water, it results in a metallic alteration to taste. But of course, this is usually when the concentration of alum is higher. And third is, when this residual aluminum is there, some studies have shown that it can lead to a partial dementia because of the residual aluminum. However, they are all controllable if you use the adequate amount of aluminum and alum. So this is about Nalagonda technique. So Nalagonda technique, as I told you, can come as a short note individually, or it can come as a part of your main question asked on defluoridation. Now just to know what are the other newer methods or other methods, there are costly equipments like electrodialysis, electrochemical diffusion, or you can use crude methods like a brick column where you are powdering the bricks, adding it to a column of, within a PVC pipe, and from top when you pass on water, this brick contains particles which are supposedly adsorptive in nature. The same effect can come when you use a mud pot. When you store the water in a mud pot, it results in removal of fluoride. There is another process called as Crass process that was developed by Agarwal and Gupta. It is a patented design where a special media is prepared, which is around 30 to 60 centimeters in thick. It is supported by gravel and sand, and that acts as a filtering medium, and they say it is a very efficient filter, and that is known as the Crass process. Then of course in rural settings, some of these products like your tamarind gel or gooseberry leaves or drumstick leaves or vetiver cizzanoids, this is popularly known as Ramacham. So the use of these products or herbs or plant products, they do have demonstrated defluoridation potential. And one of the most commonly used methods now at most of the houses is a process called reverse osmosis, abbreviated as RO. Many of the filters that we use domestically have this mechanism, but the only disadvantage of reverse osmosis is there's a lot of wastage of water. So that is the biggest disadvantage of reverse osmosis, that when water is passed through a semi-permeable membrane, there is a filtration of fluoride, of course, but reverse osmosis as a water purification system results in wastage of water, which is the major disadvantage of reverse osmosis. So what are the alternative strategies to defluoridation in case defluoridation is not permissible or not available? Identify alternate sources. Go for a piped water supply. So if the water at that particular place is defluoridated, having excess fluoride, or if the particular well is having excess fluoride, go for piped water supply. Or you can dilute the water with the non-fluoridated water. Or you can think of rainwater harvesting. This rainwater harvesting can enrich the groundwater with diluting the existing fluoride, or you can construct check dams. These are another method to enrich the groundwater and reduce the fluoride concentration in rainwater. So with that we come to the end of defluoridation and today's class. So this is a very important topic, as I have been telling you. It can come as a main question, a short essay, or a short answer question. The next class we will be discussing about therapeutic benefits of fluoride as topical fluorides and systemic fluorides. So with this we end the topic on fluoride toxicity, that is respiratory fluorosis, dental fluorosis, and how to prevent fluorosis is by defluoridation of drinking water. Thank you.